The next presenter is Bharathi, Mr. Bharathi, and you have this access. And you can share your screen if you want to. And if you are not able to do this, please let us know. Then we can share the screen for you. Share the items. Thanks. So this is. So can you share the screen?
Sir, am I audible?
Sorry to interrupt. You have 10 minutes for presenting, and then we have 5 minutes for Q&A. So please manage your time. Thank you so much.
Okay, sir. Good morning, one all present here. Myself, Bharathi, full-time research scholar under the guidance of Dr. S. Mohanaselvi, Associate Professor, Department of Mathematics, SRM Institute of Science and Technology, Kotangaladu, Chengalpattu District. My broad area of research is PSI-FUCA and PSI-PIV method for multi-attribute group decision making using single-value neutroscopic neutrality aggregation operators. My outline of the presentations: abstract, introduction and literature review. Then I go to the basic concept, single value neutroscopic weighted neutrality aggregation operator, and then order weighted neutrality aggregation operator, followed by this application to multi-attribute group decision making problems, comparative studies, conclusion, and then reference. Abstract. This studies represents a comprehensive investigations into multi-attribute due decision making under uncertainty by employing single-value neutroscopic set to effectively represent imprecise, indeterminate, and inconsistent information. In my paper, I am using existing single-value neutroscopic neutrality aggregation operators to construct a group decision-making approach. In this studies, I am using this method to find the weights of the attribute, and then I finally use a FUCA and PIV method to rank the alternatives. Followed by this, I am finally a numerical example are provided to illustrate the validity, effectiveness, and practical applicability of the proposed methodologies. Origin of neutroscopic set. In real-world decision-making, information is often unclear, contradict, and incomplete. Zare designs a fuzzy set theory to process imprecise data by considering new membership degree. Later, that intuitionistic fuzzy set is an extension of a fuzzy set theory. Then Pythagoras fuzzy set, Fermatian fuzzy set, and Q-rank orthogonal fuzzy set are introduced by considering the membership degree and the non-membership degree, which are dependent. In Q-rank orthogonal fuzzy set, when Q is equal to 2, it becomes a Pythagoras fuzzy set. When Q is equal to 3, it becomes a Fermatian fuzzy set. Then picture fuzzy set was introduced by considering the independent neutral membership degree along with the membership degree and the non-membership degree. Spherical fuzzy set, cubical fuzzy set, and T spherical fuzzy set are introduced. When T is equal to 2, it becomes a spherical fuzzy set. When T is equal to 3, it becomes a cubical fuzzy set. Neutroscopic building on a intuitionistic fuzzy set, neutroscopic fuzzy set were introduced by Samaranchi in 1999 by considering the independent membership degree, which is truth, falsity, and the intermediate membership functions. This table represents the characteristic of neutroscopic sets. Here again we can see that neutroscopic set is a three-dimensional, and the membership degrees are truth, falsity, and the intermediate membership degrees are independent. The extension of fuzzy set and the intuitionistic fuzzy set membership degrees are dependent. From the above table and figure, it is clear that single value neutroscopic is more powerful in handling the uncertainty situation, which are values of 0 to 1 compared to the fuzzy set extensions. Inspired by the capacity of the single value neutroscopic in assuming more values to the 3 degrees of membership, this paper instead interested in conducting a research studies of its applications. While dealing with the decision-making situations in various fields, many researchers develop several decision-making approaches under different fuzzy environments. Among the various aggregation tools, neutrality-based aggregation operators have demonstrated considerable potentials in accurately capturing the neutral activities of the decision makers. Despite their significance, the application of neutrality aggregation within single-value neutroscopic framework, particularly in group decision-making scenarios, has revised limited attention. To address this gap, this paper introduced a PIS method for finding the weights of the attributes. Then we use a FUCA and PIV method to rank the alternatives. Finally, a comprehensive numerical example is provided to illustrate the ability and effectiveness of the proposed approach, followed by this a comparative studies with a numeric existing methods or a basic concept of single valley neutroscopic set. Definition 1 represent the def, single valley neutroscopic set. Followed by this definition, here I mentions the score and accuracy functions of a single valley neutroscopic number. Definition 3 represent the neutrality aggregation operator. This is the existing operator, which is a single valley neutroscopic weighted neutrality aggregation operator. Followed by this definition, here I prove the theorems by using the mathematical induction proof. These are the properties which is necessary properties for these aggregation operator: idempotency, boundedness, and monotonicity. Similarly, here I define the order weighted neutrality aggregation operator for single value neutroscopic environment. Followed by this, I prove the theorem 2 also. Algorithm, hybridization, group decision making methods. First, we have to consider the set of alternative set of attributes, then form a group decision making matrix. First, we have to find the modified PSI approach. PSI PSI is used to calculate the weight of the attributes by it is an objective determinations of weight of the attributes. PIS-FUCA method. The FUCA method is combined with the PIS method to form the PIS-FUCA approach. First, we have to rank the alternatives with the benefit and cost types. Then we have to apply the score for find this matter. Then we finally rank the alternative based on their respective values. Here PIY method. First, calculate the score values of each SVN, normalize, then compute the weighted normalized, then calculate the weighted periodic index with the benefit type and the cost type, determine the total scores of each alternative, finally rank the alternative. Numerical illustrations, let's consider the existing example. For we have to, in this example, we have to select the best companies based on the four criteria. Here WK represent the decision makers weights. In this example, there are 3 group decision makers. First, we have to aggregate. Then we must find the attribute weight. Then then use this weight this method attribute weights to combine with the FUCAS method. Here here alternative 3 is the most preserved best alternative. For alternative 3 is 3 companies one best alternatives. In similarly for PIY method, alternative 3 is a preserved one. Comparative studies, in this paper I have compared uh, my methods to the other methods. Table This table represents the comparative studies. My best alternative is 3, but the existing operator best alternative is 2. Conclusion: in this study, hybrid models of group decision making methods are proposed, combining the PIS with the FUCA and PIV approach. The hybrid models PIS, FUCA, and PIS-PIV are used to rank the alternative by applying FUCA and PIV method. While the attribute weights are determined using the PIS method, these methods are integrated with the existing single value neutroscopic weighted neutrality aggregation operator to enhance the decision making process. This comparison provides valuable insights into the performance, accuracy, and availability of each method, and uh, highlighting their strength. The finding contributes significance to the development of more robotic and efficient decision making technique, offering a foundation for future research and advancements in this area. These are my reference. Thank you, sir.
Such wonderful information, wasn't it?
It was, surely.
Thank you.
Thanks for your presentation and thanks for your time management. Now we have 5 minutes for Q&A. If there are any questions, Dr. Michael. Oh,
you. Thank you for your presentation.
Thank you, sir.
What is the main motivation for development and using neutral aggregation operator for single value set? What are the
Sir, your
advantages?
voice is breaking, sir. I couldn't understand that. Your voice is breaking.
Yes, I will speak slower and send you by chat. Okay, you can see. What is the main motivation for developing and using on neutral aggregation operators? Can you hear me?
Yeah,
I see.
if an x gives an equal degree to each element, that is showing a neutral character towards the process, then the overall comprehensive values by applying the existing aggregation operators. So I'm using this neutrality aggregation operator in this method.